see the first two numericals, the 7 numericals given to you. And question is find the magnetic field for all questions. So these two questions we already solved. So I can remove this two question from the board. Okay. Now one by one you can see them like this one. These are the on the line solomagnetic field. Okay. Now let recording is on now. Let this is first, this is the second one. So net magnetic field, we can write magnetic field into the first one. Last. Am I audible? Hello?
Yes, sir.
We have to find out the magnetic field due to these two semicircular ring. So let for the first one is 1, let for the second one is 2. So we can write B1 plus B2 from the right hand curl rule. For B1 it is cross and for B2 is also cross. So mu naught I 4 pi, the radius of the first one is R1, angle is pi, cross plus mu naught I 4 pi R2 pi cross. So we can take mu naught I by 4 common, 1 by R1 plus 1 by R2 cross. Can we write this? Can we write this? Yes or no? Hello.
Yes, sir.
Now try for this one. Try for this one. Try for the next one. Let this is the first one, this is the second one, this is the third one. So we can write total magnetic field for the first one outward. So I can write dot. Second one is cross. I can write B2 cross. Third one is dot. So I can write B3 dot. Here. Now they all are full circle. So for the first one, mu naught, current is 3I, 4 pi, radius is R, and angle is 2 pi. Why full circle? And this is dot. Now the second one, mu naught, current is 2I, 4 pi, radius is R, 2R, angle 2 pi, cross. The third one, mu naught I, radius is 4 pi into 3R, 2 pi dot. So try this to calculate the net magnetic field. Try this to calculate the. So best way is that first you can cancel this 2, you can cancel this 2, you can cancel this 2. So what we have mu naught I by 2R if we take common. So here we have 3I. See, one thing is very clear, if the denominator value less and that numerator value high, so that is the more value or large value. So you can say you have 2 dot and 1 cross. So overall dot is greater value than cross. So we can suppose dot as a positive and cross as a negative. So the net value is dot. So I am taking that dot as a positive because the dot is greater value. So my final result is in dot. So mu naught I by 2r, here you have 3i, sorry, 3. I thought we take common 3 here. This 2 I can cancel mu naught I by 2r, but this is dot, this is cross, so I can take -1. And here this 2 mu naught I by 2r, if we take common, this is dot. So first one and last one same value, so plus, and the value is 1 by 3. So overall it is dot. Everyone, is it clear that part? देखो ये दोनों डॉट है, ये क्रॉस है, ये दोनों का वैल्यू को हमने ऐड किया और इसको सब्ट्रैक्ट किया, नेट वैल्यू को डॉट लिखा. मतलब मानो ये दोनों these all are वेक्टर, ये दोनों प्लस आई है, ये माइनस आई है, तो दोनों का प्लस आई माइनस आई इक्वल्स टू आई. ठीक है, प्लस आई में जाएगा. सो ओवरऑल व्हाट यू हैव, ओवरऑल यू हैव म्यू नॉट आई बाई 2r, यहाँ पे हो गया 6 + 1 7 by 3 dot, that is 7 mu naught I by 6r dot. Clear everyone? Is it okay everyone? Everyone, is it okay?
Yes, sir. Yes, sir.
Yes, sir.
So now this one is done. This one is done. Now the next one is, if I try this one, see, let it be 1, let it be 2. So I can write net magnetic field, that is B1 plus B2. I can give a gap so that we can put the direction. So this is cross, sorry, the current is this, the magnetic field is outward. Outward means dot or cross? Dot. And this one cross. So now for the first one, mu naught I 4 pi, the radius is R1, semicircle, so we use pi, this is dot, plus mu naught I 4 pi, the radius is R2 pi, and the value is cross. So what we have, mu naught I by 4 R1 dot plus mu naught I by 4 R2 cross. Now tell me, this R1 dot R2 cross, which one is higher value overall? Hello? Hello? Anyone please tell me, am I audible?
Sir, R2 cross.
See, the lower value means overall value higher. So we can say this one is higher than this one, yes or no? So mu naught I, we can take 4 common, 1 by R1 minus 1 by R2. As dot is greater than cross, so I can write overall dot. Yes? Yes or no?
Yes, sir.
Okay. So after this, the next one is, after this, the next one is this one. See, these all are on the line, these all are on the line, these all are on the line. So on the line, magnetic field is 0. So you have magnetic field only for this 3. So let it be 1, let it be 2, let it be 3. So net magnetic field due to 1, due to 2, due to 3. Now for 1, the current is this one. So my magnetic field into the page cross. Now for the second one, my magnetic field is this one, means dot. The third one, my magnetic field is cross. So mu naught I 4 pi, this distance is 3r, and this angle is theta. This distance is 3r. This angle is theta cross. Now the second one, mu naught I 4 pi. This distance is 2r. The angle is theta and dot. Mu naught I by 4 pi. This distance is r. This angle is theta and this is cross. Yes or no? So on that basis, what we can say, if we take mu naught I by 4 pi r theta common, because see 2 cross we have 1 dot, so that means cross is greater than dot. So we can take the most common part, mu naught I by 4 pi r theta. So mu naught I theta by 4 pi r. So 1 by 3 remain. We use the cross as a positive, mu naught I theta by 4 pi r. So minus 1 by 2, because this is positive, this is negative, and again this is positive, mu naught I theta by 4 pi r. So plus 1. And overall cross. So what we have, mu naught I 4 pi r theta. This is 6. 2 minus 3 plus 6 cross. So what we have, 6 2 8 minus 3 5. 5 mu naught I by 6 12 12 12 24 pi r theta cross. That is my overall magnetic field. Okay.
Yes, sir.
Next one. Everyone, is it okay? Everyone okay? Everyone okay?
Yes, sir.
Now the last one. See, if you see it properly, the total angle is 360 degree and all are equally spaced angle. Total eight circular arc is there. 1 2 3 4 4 big, 1 2 3 4 4 small. So 360 divided by 8, that is pi by 4. That means each is pi by 4, that means 45 degree. So I can suppose total magnetic field is 4, the smaller one. Obviously, they all are in the same direction, dot, plus 4, bigger one, the direction dot. This smaller radius, bigger radius. So 4 into mu naught I 4 pi, the smaller radius, suppose we can suppose this one as a B1 is R1. Suppose the bigger one, angle is pi by 4 dot plus 4 mu naught I by 4 pi R2 into pi by 4 dot. So see, basically you can see this 445 degree is 180 degree. That means semicircular this one and this 4 combined becomes semicircular. So you can cancel this 4 you can cancel this 4. So you have mu naught I by 4 pi 1 by R1 1 by R2 overall dot. Here everyone. Everyone, is it okay? Everyone, is it okay?
Yes, sir.
Yes, sir.
So now the next very important one. The next very important one, that is magnetic field due to infinitely long current carrying conducting wire. ये हम लोगों ने देखा था circular coil. Now we see the straight current carrying conducting. Both derivations are very, very important. Every alternate year, either they give you the straight or they give you the circular. So the question is that now it's a question. You have an infinitely long current carrying conducting wire. P is a point which is at a distance y from this current carrying conducting wire. You have an elementary length dl which is at a distance r from here, which makes an angle theta. Now this deep line means it's a finite, and if you make it dotted, that means it's infinite. So we derive it in such a way that we can find out for the finite, then we can find out for the infinite also. So we can say, according to Biot and Savart law, this distance is r, this is theta, this is dl, this is the perpendicular distance, this is the perpendicular distance, 90 degree. So according to Biot and Savart law, we can say magnetic field at point P is mu naught by 4 pi I dl sine theta by r squared. Now, if we let it be the equation number 1, now if we see this equation, mu naught by 4 pi I dl sine theta by r squared, we realize that r is also variable, theta is also variable, this length L is also variable, this length dl is also variable. If we suppose this length is L, so this dl is also variable. So we have this all three, r is also variable, theta is also variable, dl is also variable. So as these three all are variable, we don't know how to find out the triple integration, because dl is variable, theta is variable, r is also variable. So that's why we do one thing, we convert this all variables into a single variable. We try to make it a single variable, and to avoid the angle problem also, means if you use this angle, so then you have a negative and positive sign. So to avoid this angle, we use, let this angle is phi. If we suppose this angle is phi, so I can write this angle is 90 minus phi. Yes or no? Can we write that? Yes or no? Yes or no? Hello? Hello?
Yes, sir.
Yes, sir.
So first of all, if we say sine theta, now see my sine theta, I can write sine theta is 90 minus phi. So 90 minus phi, that is cos phi. Can we write this?
Yes, sir.
Now let it be equation number 2. Tan phi, what do you mean by tan phi? See, if this is my phi, perpendicular by base, that is L by y, which means we can say y tan phi is L. I want this dl. So if we differentiate, y tan का differentiation क्या होता है? Sec square phi d phi, that is dl. Are you satisfied with this?
Yes, sir.
We differentiate y tan phi. So differentiation of this tan phi is sec square phi d phi, that is dl. Here, everyone? Yes, we know differentiation of tan phi is sec square phi. Yes or no?
Yes, sir.
Now we also know sec means 1 by cos. So 1 by cos square phi d phi is dl. We can write it. Question number 3. So we change the theta, we change the dl. Now only remain is r. So for r, we use cos phi. What do you mean by cos phi? Base upon hypotenuse. So this is my base y by r. That means 1 by r what we can write? Cos phi by y. Can we write this? Can we write this?
Yes, sir.
So 1 by r square, we can write cos square phi by y square. Let it be equation number 4. Is it clear, everyone?
Yes, sir.
Yes, sir.
Now putting the value of equation 2, 3, 4, putting the value of equation 2, equation 3, equation 4 in equation 1. So what we have, let's check dB, that is equals to mu naught by 4 pi I. Now dl, instead of dl, I can write y cos square phi d phi. Yes or no? Yes or no? হ্যালো, আরে তোরা কিছু বলছিস না কেন রে?
হ্যাঁ স্যার।
আমার কি গলা কি কেটে কেটে যাচ্ছে আমার আওয়াজ?
না স্যার।
So now sin theta we can write cos phi. The sin theta is cos phi, and 1 by r square, this 1 by r square we can write cos square, this 1 by r square we can write cos square by phi. Yes or no? Yes or no?
Yes, sir.
So 1 by r square is cos square by 1 by r square is cos square phi by y square. So that means in this equation 1, we put the value of equation 2, we put the value of equation 3, we put the value of equation 4, and what we realize now, see, after that, this cos cancel, 1 y cancel. Now we have mu naught by I y cancel, mu naught by 4 pi I by y cos phi d phi. Look at this properly. Let it be equation number 4, 5. Let it look at this equation number 5. See, mu naught by 4 pi is a constant, I is a constant, y is a perpendicular distance constant. The only variable is cos phi. So basically, this three different values we can convert into one single variable. So now we can easily integrate this. Clear, everyone?
Yes, sir.
So now let's integrate them. So before integrate, I want to write it properly in a proper place. So my dB is, after putting all the values, after calculating all the values, is mu naught I 4 pi y cos phi d phi. So I am tearing the whole board so that you can understand. Now, first, if we try to find out the finite, so this is my 1 point, and suppose this is my 1 point. These are my the 2 points where my angles are finite. Now see, if we use this angle, tell me this angle, you are moving clockwise or anti-clockwise? This angle, you are moving clockwise or anti-clockwise? Hello?
So
Clockwise.
Clockwise.
When we take clockwise angle, it's a positive or negative? When we took clockwise angle, it's a positive or negative? Ball?
Positive.
Up marbo na. This is anti-clockwise, theta is positive. If we take clockwise, theta is negative. Gadha sob. You remember? Hello? এটা হচ্ছে এক্স অ্যাক্সিস, আমি যদি মনে করি এখানে আছি, এটা 30 ডিগ্রি, প্লাস লিখবো না মাইনাস লিখবো?
Plus.
প্লাস লিখবো না মাইনাস লিখবো?
Minus.
তার মানে কি হচ্ছে, অ্যান্টি ক্লকওয়াইজ পজিটিভ, ক্লকওয়াইজ নেগেটিভ না? unnecessary সময় নষ্ট করতে হয়। So this one is my clockwise negative, let it be 5 1, and this is my clockwise, let it be 5 2. So now I can write, to find out the total magnetic field, to find out total magnetic field at point P, taking integration both sides, with proper limit. So integration of dB mu naught I 4 pi y integration of cos phi d phi. The lower limit is minus phi 1, upper limit is phi 2. 0 to magnetic field at point P. Magnetic field at point P, mu naught I 4 pi y. What is the integration of cos phi? What is the integration of cos phi? আরে তোরা সাইলেন্ট মোডে চলে যাস কেন রে? হ্যালো,
হ্যাঁ স্যার, আছি স্যার।
integration of cos phi. হ্যালো,
হ্যাঁ স্যার।
cos phi এর ইন্টিগ্রেশন কত হয়? sin phi, কিছুই জানিস না? phi
Yes, sir.
1. So mu naught I 4 pi y sin phi 2 minus sin minus phi. Minus sign মানে minus minus point. So that is the plus point, that mu naught 4 pi y sin phi 1 plus sin phi 2. Means you don't take any positive negative jhanjat. That's why we convert it into phi, that we take both the angle, both the inner angle. So no tension about the negative and positive side. Means both angle are obviously maximum 90, otherwise less than 90. So you get the value always positive, no confusion. Otherwise, if you take this one, someone is positive, someone is negative, then you have a sign convention problem. Which one is positive, which one is negative? One is greater than 90 degree, one is less than 90 degree. So I'm trying to avoid this problem, and to avoid this problem, I'm writing here phi 1 plus phi 2. Now, if my wire is infinitely long, is it okay, everyone, up to this? Hello? Up to this, is it okay?
Yes, sir.
Now for important note, means this is the derivation, and with this derivation sometimes they give you some legend, means they give you some extra thing to find out for infinitely long. For infinitely long, theta, sorry, phi 1, देखो ये बड़ा होते 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 phi 1 is 90 degree and phi 2 is also 90 degree. So my magnetic field at point P is mu naught I 4 pi y sin 90 degree plus sin 90 degree, that is mu naught I by 4 pi y 1 plus 1, that is mu naught I by 2 pi y is my magnetic field. Clear, everyone?
Yes, sir.
So this is for infinitely long wire. Magnetic field at point P is mu naught I by 2 pi y. That is for the infinitely long wire, mu naught. Sometime examiner can ask you also, not the infinitely long, for semi-infinitely long. See, in the same question, if we If we cut that part, if we remove that part, so now it will be look like this part is infinity and this part at the line. So the angle is not infinity. They can make you 30 degree, 60 degree, and sometimes they make you semi-infinite. Matlab, this angle is 0 degree. If this angle is 0 degree, so I can write phi 1 is 0 degree and my phi 2 is 90 degree. So my magnetic field is mu naught I by 2 4 pi y sine 0 degree plus sine 90 degree. So which is very simple, mu naught I by 4 pi y. So I can something just remember infinitely long mu naught I by 2 pi y, semi-infinite mu naught I by 4 pi y. And if they give you some value, mu naught I by 4 pi y sine theta 1 plus sine phi 1 plus sine phi 2. Clear everyone?
Yes, sir.
So if it is okay, now we can see some numerical related to that. And for that, you only need you only want to know this formula. Otherwise, everything is same. So let's try some numerical. Question is find the magnetic field at point. Find the magnetic field at point P. Find the magnetic field at point P. Question number 1. This is the point P. I is the current. Radius is R. This is question number 1. Now question number 2. I'm just giving you some simple questions. P. From here it is semi-infinite. Both are radius is R. I is the current. The third one is point P. Radius is R. I is the, then number 4. Point P. This length is 2a. This length is also 2a. To find the magnetic field at point. So first I give you just 4. You try this 4 question. Then later on I give you the rest questions also. See, for the first question, see this is semicircular. This is on the line, right? This one is on the line. So we are not taking on the line magnetic field. So we have two magnetic field, 1 and 2. This is my first one. This is my second one. And third one, as it is on the line, so no magnetic field we can find out for the third one. So how can we find out magnetic field? For the first one, I can write cross. For the second one also, I can write cross. Now for the first one, I can write dot I 4 pi, my distance is R. So I can write R. 0 plus sine 90, sine 90 is 1 plus this is mu naught I by 4 pi R. This is a semicircular, so pi cross. So what we have, mu naught I, this is cross, 4 pi R cross plus mu naught I by 4R cross. So what we can write mu naught I by 4R 1 by pi plus 1. Yes, everyone? Everyone, yes?
Yes, sir.
Now, after the first one, let's try the second one. Second one. See, second one, this is cross. And if you see, this is sorry. This is my cross, and this is also cross, and this is my cross. So all these three are crossed. So I can write this is my one, this one, 2, and 3. This one is cross, this one is cross, this is also cross. So I can write net magnetic field B1 cross, B2 cross, B3 is also cross. Okay, so how we can write it? Mu naught I 4 pi, the radius is R, 0 plus 1 cross. Why? Because one is semi-infinite, sine 0 is 0, sine 90 is 1, plus then we have semicircular, mu naught I 4 pi R into pi cross. Then this is semi-infinite again, mu naught I by 4 pi R sine 0, 0 plus sine 91 cross. So what we have mu naught I by 4 pi R cross plus mu naught I by 4 pi, 4R cross. Then we have mu naught I by 4 pi R cross. So if we take mu naught I by 4R common, we have 2 by pi plus 1. Now in the same question, suppose instead of this is moving down, instead of this is moving down, this question is complete. Now I give you one more question. Instead of this is moving down, if it is moving up, sometime examiner can give you this type of question. Now in that time, exactly the opposite thing happens. See, cross dot, sorry, cross. Now this is dot. Yes or no?
Yes, sir.
Moving up, then dot. So if it is third one is dot, so for the next question, third one complete, second one complete. Now I give you one more question where this is not cross, this is dot. If this is cross, this is dot, this one is cross, this one is dot. So I can cancel these two. So then my magnetic field is mu naught I by 4R cross. Here everyone, these two are cancel each other. See, this is cross and this is dot. If it is moving down, then dot cross, but as it is moving up, so it is a dot. So you can check it whether it is a cross or dot. On that basis, you can take the decision. Clear, everyone? Done?
Yes, sir.
Yes, sir.
So after that, the next question. After that, the next question, if we see this one, so this is a infinitely long. It is moving outward, and this is also moving outward. So basically, here you have 1 and 2. So magnetic field due to 1, which is out of the page dot, plus B2 also out of the page dot. So we can write mu naught I 4 pi R, because R is the radius which is perpendicular. And here sine 91 plus sine 91 dot plus mu naught I by 4 pi R. It's a full circle, means 2 pi dot. So what you have, mu naught I by 2 cancel, 2 pi R dot plus mu naught I by 2R dot. So we can write mu naught I by 2R 1 by pi plus 1 dot. Yes. Everyone, is it okay?
Yes,
Yes,
sir.
sir.
If it is okay, then the next question, see, it's a square. So this length is 2a, this length is 2a. I can say this is half. And as it is the square, This angle is 45 degree. This angle is 45 degree. And all these are outward, or you can write outward. So instead of finding all this, you can find 1 and multiply it by 4, because similarly you have 4 wires. So you can write 4 into mu naught I 4 pi, the perpendicular distance is A, and here the angle is 45 degree. So you can write sine 45 degree plus sine 45 degree, and it is outward, means dot. Pi A 1 by root 2, 1 by root 2 dot. So what you have? Mu naught I pi A 2 by root 2 dot. That means root 2 mu naught I by pi A dot. Done. Everyone, is it okay?
Yes, sir.
So apart from this, in examination, examiner can ask you some more type of question. I just give you, like it's a very popular one. Examiner asks you to look. Suppose this is current I1 and this is current I2. This is the center. They give you the same radius. They can give you the different radius. They give you the same current. They give you the different current. So if we suppose this is 1, so my magnetic field is this one. That means magnetic field is this one. If we suppose this one, so my magnetic field is this one, V2. So net magnetic field is the vector sum. So I can write they are perpendicular to each other. So net magnetic field by 1 plus magnetic field by 2. So net magnetic field root under V1 square plus root under V2 square. Here I just give you different value of current. If they give you the different same value of current, so different thing happen. Mu naught I, as it is a full circle, you can write directly 2R, 2I1R. I think you understand. If 4 pi r into 2 pi, 2 pi, 2 pi cancel 2R. So for full circle, I can take it directly. Only here I take the value I1. Similarly, mu naught I2 by 2R. Yes or no? Different current.
Yes,
If
sir.
I take the common part, mu naught by 2R, I1 square plus I2. You can solve in this way. This is one type of question. Another type of question which is very, very important. This one done? Hello? Is it okay, everyone?
Yes, sir.
Yes, sir.
So if this one is okay, then the next one is suppose they given you this type of question, and this type of so many questions they can give you. They can give you like this one question. They can give you like this. Second question. They can give you circle. They can give you third number question. They can give you even any angle also, like this angle is suppose they're giving you 60 degree. Or sometimes they make it very much complicated, like they can give you cylinder. Except if they are not saying about any resistance or anything about the conductor, that means we can suppose these are uniformly distributed. As uniformly distributed, in all of this, your net magnetic field is 0. I can show you one by one. Suppose I am trying to show this one. If this is my current, This I current is divided into pi I by 2I. Yes. Now in this two, it is suppose cross. Now in this two, it is dot. Yes or no? Suppose they give you this and this length is 2A. They give you this is 2A. So I can suppose this is A. I can suppose this is A. Let it be. This is the whole. This one is B1. The whole. This is B2. So what about this? B is equals to B1. That is cross, and B2, that is dot. You just remember me in that way. In all these situations, the magnetic field is zero. Now, if you want to calculate this, see 2 into 2 wire you have mu naught I by 2, half of the current, 4 pi perpendicular distance is A sine 45 plus sine 45 cross plus 2 into mu naught I by 2, 4 pi A sine 45 plus sine 45 dot. So what is clear, everyone? Yes or no?
Yes, sir.
Now, if you see the second one, see here you have three part of the wire. Here you have one part of the wire. So if we suppose each part of a resistance is R, here 3 wire, you have 3 R resistance. Here you have 1 wire means R resistance. So if I want to distribute the current, so we know current in parallel connection is inversely proportional to resistance. So this is 1 by 3R, this is 1 by R. So the ratio is 1:3. So what about I1? 1 by 4 of the total current. What about I2? 3 by 4 of the total current. Now this is B1, this is B2. So B is equals to B1. What is the value? This is cross or dot? See, this is cross. And what about B2? This is dot. This one is dot. Now in B1, you have 3 wire. So you can write 3 into mu naught I. Again, suppose this is A or 2A. প্রত্যেকটা A 2A করেছে, এটা A করলাম. Doesn't matter. So this is A by 2. Just use your brain. Mu naught. This I1 is how much? That is very, very important. I1 by 4 pi A by 2 sine 45 plus sine 45 plus one part, only one, mu naught I2. That I is very, very important. When you have this type of distribution, sine 45 plus sine 45. This one is cross, this one is dot. Now see, from this I1 and I2 ratio, we can say this is 1/4 of I, this is 3/4 of I. So my total value 3 mu naught. Now this is 1/4 of I by 4 pi A by 2 sine 45 plus sine 45 cross plus 1 into mu naught. This is 3 by 4I. 3 by 4I by 4 pi A by 2 sine 45 plus sine 45 dot. Now see, here you have 3 1 by 4. Here we have 1 into 3 by 4. Because they are exactly same. So you can write it 0. Yes or no? Same way you can distribute this. This is I, half ऊपर वाला में जाएगा, half नीचे वाला में जाएगा. As half of जाएगा, it's a very simple. Let it be first, let it be second. For this to be equals to B1. This one is cross, and B2. This one is dot. So mu naught I by 2, 4 pi R, let the radius is R, into pi semicircular cross mu naught I by 2, 4 pi R pi dot. Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
Now the last one, see, as they give you some angle, so the problem is how you distribute their current. Okay. So let for the upper one, the resistance is R1, the lower one, the resistance is R2. Obviously, it's a parallel connection. So what do you mean by 60 degree? 60 degree means pi by 3. So what is the remaining angle? 2 pi minus pi by 3. That is 5 pi by 3. So upper one angle is 5 pi by 3. So obviously, the higher angle, higher value, higher, more amount of material, high resistance. So if I say let the total resistance of the wire is R, what about my R1? So you can distribute here angle wise. So we can write total resistance is R per unit, total angle is 2 pi into angle of that part. How much is the angle? 5 pi by 3. So what you have, the resistance is 5 bar by 6. That is the upper one. What about R2? Let the total resistance is R per unit, total angle is 2 pi, and the angle of that part is how much? Pi by 3. So what you have? R by 6. So as you have now the resistance R1, R2, so you can easily find out the current also. 1 by R1 is to 1 by R2. That is 6 by 5 R is to 6 by R. So 1 by 5 is to 1. That means 1 is to 5. So what about I1? I1 is 1 by 6I. I2 is 5 by 6I. Yes or no? Yes or no? Hello.
Yes, sir.
Yes, sir.
So once you find out the current, now let's suppose these two are on the line 0. Now let it be B1, let it be B2. So total magnetic field is B1 plus B2. Let the current is I1, let the current is I2, which you already find out. Less value of resistance, more current, more value of resistance, less current. This one is cross and this one is dot. So they are auto adjusted. See, mu naught, first one is I1, 4 pi, the radius is R into this angle is how much? 5 pi by 3 cross. Now mu naught I2 4 pi R. This angle is pi by 3 and dot. Now see, more angle, less current, less angle, more current. So they are auto adjusted. See, mu naught, the current is 1 by 6, 1 by 6, 4 pi R into 5 pi by 3 cross. Now this is mu naught I2 is 5 by 6 I by 4 pi R into pi by 3 dots. So basically what happened, this pi cancel, this pi cancel. So 6 12 3 6 18, 6 12 3 6 18 উপরে 5 উপরে 5 0. So this type of question is complicated from not asked in entrance board exam. In board exam, they ask you the simplest form, just make it half of, but they can ask you in entrance exam. Whenever they ask you entrance exam, don't need to write all these things. Don't need to write all. Okay, don't need to write all these things. Just write the answer is 0. Here, everyone.
Yes, sir.
Okay, so if they give you like this, what is the magnetic field at the center? Don't think twice. If you see the answer is given in the question is 0, option is there, so you put the option 0. Here, आधा इसके लिए, आधा इसके लिए. Even they give you this type of question, not this one, then also the 0, because on that basis automatically current distributed, and on that basis you get the answer 0. Here, Okay, everyone.
Yes,
Is it
sir.
okay? So that is the most complicated part, you can say, from where so much numericals examiner can ask you, even in board exam, even in entrance exam. So you can practice. हम लोग कम से कम कल और आज मिला के, नेक्स्ट क्लास और आज मिला के कम से कम 16-17 न्यूमेरिकल तो किया ही होगा. Next, from next day we start the rest part, which is very, very interesting and very, very important. So for today, up to this, हम लोग यहाँ पे ही अपना लेक्चर कंप्लीट करते हैं. So thank you so much. मैं कल तक तुम लोगों को इसका अपलोडिंग दे दूंगा. ठीक है. Bye bye everyone.
Bye, sir.